ActiveMQ is probably the most versatile enterprise messaging system currently in the market. It touts a vibrant user base as part of a healthy open source community with 15 years under its belt. This has produced a standards-compliant and scalable product that is capable of handling a wide range of enterprise messaging use cases. ActiveMQ is widely utilized throughout enterprises and behind the scenes in many software as a service, commercial, and cloud offerings. It can be deployed to bare metal servers, virtual machines, containers, and scaled down to embedded compute along the lines of a Raspberry Pi. So what are the benefits and trade-offs with ActiveMQ and when to use it? Starting with some trade-offs. ActiveMQ's flexibility, while a huge attraction, can be overwhelming at first. Administrators and developers may experience early frustration when their use case isn't the default. It might help to understand that ActiveMQ is essentially a library, so there are a number of different ways to run it. Also, the default packaging from the Apache open source project, it's not always the most optimal for general enterprise use cases, specifically ones that require Active Directory or LDAP for security. Now, documentation and sample code is about what you'd expect from a popular open source project with this long of a history. There is no shortage of blog posts and Stack Overflow articles. However, many times the information isn't exactly current or doesn't clearly define which use cases are the subject of the post. ActiveMQ is super fast. However, you have to tune it. And to tune it correctly, you need solid alignment between development and operations in order to get the balance between reliability and speed just right. Let's dive into the benefits. This may sound familiar because we were just talking about tuning options, but they're abundant in ActiveMQ. ActiveMQ is able to provide strong, reliable, and one-time message delivery guarantees. It also has the ability to loosen those restrictions in favor of higher throughput by deferring some of that reliability up to the environment. ActiveMQ supports many messaging protocols and has mature client libraries to allow connectivity for many operating systems and programming languages. This includes Java, C#, Python, JavaScript, and the list goes on. A key piece to ActiveMQ's value is the number of architectures that it supports. ActiveMQ can run as a single node and go from there. Multi-node architecture patterns include application firewall, store and forward, active-active data center, hub and spoke, and there's a number of architectures that are combinations of these patterns. Because of this, operations teams do not have to settle for performance ceilings that come with all-in-one cluster designs, and it also allows for mediating usage costs when sending data across metered networks. ActiveMQ's ability to be embedded extends beyond running as part of an application deployment. It's super handy to leverage an embedded ActiveMQ within an integration test to validate failover and error handling. Now, this capability is not limited to a single broker, and tests can be written against an embedded cluster that mirrors the production architecture. ActiveMQ is often called the Swiss Army knife of enterprise messaging systems for good reason. ActiveMQ is a proven open source technology. It's standards-based, extremely versatile, and capable of handling a wide range of messaging use cases.